Greetings, ladies and gentlemen. I welcome you all to TV Mathshub. In this video, we are looking at pure mathematics revision questions to help you test your understanding, sharpen your logic, and prepare you for your next examinations. The questions that we shall look at are carefully selected to cover some of the key areas in pure mathematics. Pause the video after each question, take time to work it out, then check the answer and the explanations that follow. No tricks, just solid mathematics thinking. Let's get started. We shall look at question number 1. We shall be generally looking at two alternative methods of how best we can show that the modulus of this expression is equal to 4 square root of 2. So we shall begin with method 1, where we shall be taking the modulus of the whole of this. So the modulus of this expression is same as taking the modulus of the numerator and the modulus of the denominators respectively. We understand that the modulus of z1 upon z2 is same as modulus of z1 divided by modulus of z2. So using this property here, we can generally do this, meaning that we can take the modulus of the numerator, which will be same as this, and the modulus of the denominator, which is same as taking the magnitude of 1 plus I, and here 1 minus I to the power of 6. So the modulus of a complex number, if z1 is your complex number x plus iy, then the modulus of z1 is same as the square root of x squared plus y squared. So meaning we shall be taking the modulus of 1 minus I, and it will be same as the square root of 1 squared plus the imaginary part here is negative 1, so squared, and the whole of this is to the power of 6, then divided by the modulus of 1 plus I, which is same as that. So this will be able to give us the square root of 2, but the whole of it is to the power 6 divided by the square root of 2, and this will be the square root of 5 of 2 to the power of 5. So we shall have this. But what are we interested in? We are interested in showing that the modulus is 4 square root of 2. So we need to simplify this expression such that we are able to get the required answer. So we understand that this can be expressed as the square root of 2 to the power of 4 times the square root of 2. But what is square root of 2 to the power of 4? Square root of 2 to the power of 4 is actually the same as the square root of 2 squared. Then the whole of this is also squared. So this is same as having 2 squared, which is actually 4. So this will give us 4, then square root of 2, which is same as 4 root 2. And that will be the required answer. That is by using the property that magnitude of z1 over z2 is same as magnitude of z1 divided by magnitude of z2. So let us look at an alternative method. Let us now talk about an alternative method for question number 1. And in our alternative method, we shall basically be talking about simplifying this expression first, then after we get the modulus. So if we need to simplify this, we need to simplify 1 minus I to the power 6 first. When you simplify this, you'll be able to get 8I upon 1 plus I, but we can look at the simplification first of how we can move up to this given point. Then we look at the solution in details. So we want to look at the expansion of 1 minus I to the power 6. We can get the expansion here. The most important thing is to know the coefficients, but we can easily get the coefficients using the combinations. So we can begin by 6 combination 0, 1 to the power 6, then negative I will be to the power 0. Then the powers for 1 will keep reducing as the powers for negative 1 are increasing. So 6 combination 1 1 to power 5, negative I to power 1, 6 combination 2, 1 to power 4, negative I to power 2, 6 combination 3, 1 to power 3, negative I to power 3, and 6 combination 4, 1 to power 2, and negative I to power 4. We shall again add there 6 combination 5. 1 is to power 1, now negative I is to power 5. And the lastly 6 combination 6, 1 is to power 0, negative I is to power 6. So that is how best we can uh, expand this by using the knowledge of combinations together with the terms from this given expansion. Now we shall have 6 combinations. 0 is 1, so 1 to power 6 is 1. This one will give us 1. Plus 6 combination 1 is 6, negative I, so it remains negative I. 6 combination 2 is 15. Negative I, negative squared will give us positive, but I squared is negative 1. 6 combination 3 will give us 20. Then negative I, we are having negative of I to power 3. This is same as negative I squared into negative I. And this is negative 1. So negative 1 times negative I will give us positive I. And then plus 6 combination 4 will be 15. And this 15 will be multiplied in 2. You have negative I squared times negative I squared. That is I to power 4. This will be 1. And we shall add there 6 combination 5. That is 6 into negative I to power that. This will be 1 times negative I. Because we have seen negative I to power 4 is positive 1, which means this will give us, when we are looking at negative I to power 5, it will be same as negative I then times 1, which is negative I to power 4. So this will give us negative I. And lastly, we shall have 6 combination 6 is 0, negative I to power 6. So that is same as I to negative I to power 4 is 1. So times negative I, which is squared. So this will actually give us negative, that is negative 1. So we shall have as negative 1 here. So this will give us 1 minus 6i minus 15 plus 20i plus 15 minus 6i minus 1. So this 1 and this 1 will cancel out. Negative 15, negative 15 will cancel, negative 15 and positive 15 goes out. Then we remain with 20i minus 12i. So 20i minus 12i will give us 8i. So the expansion of this will be giving us 8i. So we shall return the 8i, and clearly we can all see that when you simplify this, you'll be able to get 8i over 1 plus I. So from here, rationalize by multiplying by the conjugate of this, and it will be 1 minus I on both sides, that is in the numerator and the denominator. So this will give us this expression. This is a difference of two squares, 1 minus I squared, which is 1 minus minus 1. So that is why we have 1 plus 1. And when you multiply this, this will be 8i minus 8i squared, and it will give us 8 plus 8i upon 2. So this will give us 8i minus minus 8, which is same as 8 plus 8i. So we shall have this divided by 2, which is 4 plus 4i. So the whole of this expression is giving us 4 plus 4i. So if we are interested in the modulus of this, it is same as taking the modulus of 4 plus 4i, which is same as taking the square root of 4 squared plus 4 squared, and this is square root of 32. So simplify this. This is same as having 2 times 16 under the square root, which is same as 4 square root of 2. So looking at the two alternative methods, we shall be able to get the same answer. Let us talk about question number 2. It says sort of 2 cos 2 theta minus 5 cos theta is equal to 4 for the values of theta ranging from 0 degrees less or equal to theta less or equal to 360 degrees. So to solve this expression, we shall first of all create the relationship between cos 2 theta and cos of theta. And that relationship can easily be formed because we know from the identity that cos 2 theta is same as 2 cos squared theta minus 1, then we can easily get the relationship between cos theta and cos 2 theta. So doing that, where there is cos 2 theta, we shall substitute there. 2 cos squared theta minus 1, and that will give us 2 into, we are substituting it in this equation here. So we shall get 2 into 2 cos squared theta minus 1 minus 5 cos theta equaling to 4. So try to simplify this. This will give us 4 cos squared theta minus 2 minus 5 cos theta equaling to 4. So from here we can try to simplify, bring this 4 this side, and you get 4 cos squared theta minus 5 cos theta minus 6 equaling to 0. So from there, we need now to simplify this further by using what we call the quadratic formula. So because we can easily see that this is actually a quadratic equation, because you have cos squared here, you have cos here. So this is a quadratic equation, and we can easily solve this using any of the methods for solving quadratic equations. So using the quadratic formula, this is of course our A, this is our B, and this is our C. So for that case, we shall have cos theta equaling to, for a quadratic formula, it is negative of B, and then B squared minus 4AC divided by 2A. So negative of negative 5 will give us 5 plus or minus B squared negative 5 squared minus 4AC. 4 times F, which is 4, times C, which is negative 6, divided by 2A, that is 2 times 4. And that will give us 5 plus or minus. Simplify this, and you'll be able to get plus or minus the square root of 121. The whole of this is divided by 8. So the square root of 121 is 11. So we shall have 5 plus or minus 11 divided by 8. So clearly we shall have two values of cos theta. One of the values will be when you have 5 plus 11 divided by 8, which is 16 divided by 8, and this is 2. So we shall have that. And next we shall have cos of theta equaling to 5 minus 11 divided by 8, which is negative 6 divided by 8, and this is negative 3 divided by 4. So generally we shall have two values of cos theta. One is cos theta equaling to 2, and 2 is cos theta equaling to negative 3 over 4. So from here we shall be in a position to get the values of theta. So if you consider cos of theta equaling to 2, as theta is equal to cos inverse of 2. Cos inverse of 2 does not exist. Cos is maximum at 1 and minimum at negative 1. So beyond that, cos cannot be defined. So this one here is invalid, and for that case, it cannot be defined. Theta here cannot be defined, but let us try to look at this. We are having cos theta equaling to negative 3 upon 4. So looking at this, we realize we can easily get the value of theta. So from here, we shall be able to get cos of theta equaling to negative 3 upon 4, and it will be able to give us these different values of theta. So let us look at how best we can easily get these values for theta. One, well, you can consider cos theta equaling 3 out of 4, and you consider this as what we call a principal angle. So this is our principal angle, or what we can call the key angle. So this angle here is not part of the solution, but we generally use this to easily get the required answers. So if you use cos of theta equaling to 3 out of 4, so theta will be cos inverse of 3 out of 4. Cos inverse of 3 out of 4 is actually 41.41 degrees. So you will go to your quadrants, go to the quadrants where cos is a minus. Cos is minus in uh, in these quadrants here, the second quadrant and the third quadrant. That is where cos is negative. So place that angle there, 41.41, and here 41.41. So we can easily get those angles by taking this angle. So that is same as 180 minus 41.41 degrees. So when you get 180 minus that answer there, you should be able to get 138.59 degrees, which is this value. So I need the second angle, which is this angle here, starting from here up to this given point, which is same as getting 180 degrees plus 41.41 degrees. And this will be able to give us 221.41 degrees. So that is how best we get those answers there. Let us now talk about question number 3. So in question number 3, we need to show that the integral of 0 to 1 of tan inverse of x upon 1 plus x squared dx is same as pi squared upon 32. So we shall do this by letting first this tan inverse here of x to be in terms of another variable, for example, u. So when we let u to be an inverse of x, then it means we shall need to differentiate u with respect to x. When you differentiate an inverse of x with respect to x, you get 1 upon 1 plus x squared. So for that case, make dx the subject. When you make dx the subject here, you will have 1 plus x squared du, which is equal to dx. So our dx is same as this. So if that is the case, since we have changed our expression from x to u, so we must also change the limits. So the limits, we have the limits in terms of x, but we have changed the variable from x to u. So we must get the corresponding limits in terms of the new variable u. So changing the limits, when x is equal to 0, it means u will be tan inverse of 0. That is 0. When x is 1, it means u will be tan inverse of 1, which is pi by 4. So it means your limits will be from 0 to pi by 4. So let us now put everything in terms of u. So putting everything in terms of u, we shall be having the integral of 0 to 1 tan inverse of x upon 1 plus x squared dx, which is same as the integral from 0 to pi by 4. Tan inverse is our u. This is 1 plus x squared. Dx is actually 1 plus x squared du. So this and this will cancel. You will remain with the integral from 0 to pi by 4 of u du. And that is what we shall be remaining with here. So for that case, integrate u with respect to u, and this will give us u squared divided by 2, and our limits from 0 to pi by 4. So substitute your limits, and you will have a half into, put the upper limit, pi by 4 squared minus 0 squared. And this will give us a half times pi squared upon 16. and this will be pi squared upon 32. And this is the required answer. Let us now talk about question number 4. Question number 4 is about a plane, and the question says, given the plane 4x plus 3y minus 3z minus 4 equaling to 0, we need to show that the point A, which is 1, 1, 1, lies on this plane. For the point to lie on the plane, then it must satisfy the equation of the plane. So we shall need to substitute this point here into this equation, and we see whether it will satisfy this equation. So this point here is in the form of x, y, and z. And for that matter, it implies your x is 1, your y is 1, and your z is 1. So when you substitute x, y, and z, which are equaling to this, that is 1, 1, 1, then we shall be able to obtain this expression will be able to give us a 0. So clearly, we can see that this point 1, 1, 1 actually lies on the plane because it satisfies the equation of the plane. Next, let us talk about 4 part B. That is asking us to find the perpendicular distance from point B, which is given as 1, 5, 1, to the plane, which is given as 4x plus 3y minus 3z minus 4 equaling to 0. We shall be using the formula which says that d, the distance or the perpendicular distance, is same as the magnitude of ax naught plus by naught plus cz naught plus d upon a squared plus b squared plus c squared. So that is for when you are dealing with x, y, and z. But if you are dealing with only x, y coordinates, then it means you will simply use ax naught plus by naught then plus c, then divided by the square root of a squared plus b squared. So this is for x, y plane. But for our case, we are looking at xyz plane, so we shall be talking about this given expression. So from here, what is x naught, y naught, and c, then what is z naught? So x naught is actually the point that is given. So this is x naught, this is y naught, and this is z naught. Then from the equation, you will obtain this 1, 4 will be representing A, this will be representing B, and this will be representing C. So at times we use small letters, you can use capital, still it will be the same thing. So it means your x naught is actually 1, your y naught is actually 5, your z naught is actually 1. Then your A is 4, your B is 3, and your C is -3. Then your D is -4. So substitute them into this equation. A, that is 4 times x naught, that is 1, then plus B times y naught, plus this times z naught, then plus D, which is -4. Don't forget the magnitude because we need the distance. So our distance must be a positive value. So then take the square root of 4 squared plus 3 squared plus -3 squared. This is 16 plus 9 plus 9. That is 16 plus 18, which is 34. So you have the magnitude of 12 divided by square root of 34. So this is same as having 12 divided by the square root of 34, and you'll get 2.058 units. So this is the perpendicular distance from a given point to the plane.
Yeah.